Hello, Math World, and welcome back to IzoMath. Today we're going to talk about addition and subtraction formula for cosine. What is O? Okay, if we refer back to our unit circle, here I got a unit circle, obviously radius 1, and I'm going to call this angle here U. We should be comfortable from earlier sections that this endpoint right here has a coordinate of cosine of U, comma, sine of U, and that's what we've learned from the previous sections. What we're going to do is we're going to help this to identify how we figure out the addition formula for cosine. So if I create another line here, we know this obviously has a radius also, or has a length of 1. But I'm going to call this internal angle now V. This endpoint right here has the coordinates of cosine of V, comma, negative sine of V, because I'm obviously in the fourth quadrant where my sine value is going to be the negative. But what I can do between this is now if I connect these two guys right here, I've created a triangle, and what I'm ultimately interested in again is finding out what the cosine of U plus V is going to equal. That's what I'm curious about, and that's what we're going to discover. So we're actually looking for that angle together, added together, what the cosine of U plus V is going to equal. This is how we do that. What I do is I draw on prior knowledge. And I know this side length has a value 1, this side length has a value 1. What I'm curious is this side length. Well, if I use these two endpoints, I can go back, draw from prior knowledge that the distance between 2 points are essentially the difference between my x coordinate squared plus the coordinates, my y coordinates, difference of my y coordinates squared, and take the square root of it. So in this case, I'm going to call this side here, right here, C. C is equivalent to the square root. In this case, is going to be my cosine of U minus my cosine of V quantity squared, plus my y coordinates, which are sine of U, minus a negative sine of V, which comes out to being plus sine of V in this particular case, quantity squared. So that is essentially coming out to being, and if I square this, if I make this a C value, that helps me eliminate this nice little quantity. So I'm left with a C squared is equivalent to cosine of U minus cosine of V quantity squared plus the sine of U plus the sine of V quantity squared. Working this value out more, we come up obviously with giving us this quantity is basically cosine squared of U minus 2 cosine of U cosine of V plus cosine of V squared, and then the second piece is going to give me sine squared of U plus 2 sine of U sine of V, and plus sine squared of V. So, and then if I go through this, obviously I can try to gather together some not like terms, but some stuff that's going to help me make my life a little easier. I can see I got a cosine U, and also a squared U, and also have a sine squared of U. Put those two guys together, I see another cosine squared of V plus a sine squared of V, and gathering those terms together. And then what's left over is also 2 cosine of U cosine of V plus a 2 sine of U sine of V. And the advantage of this, obviously, we know that this value has a 1, that's a value 1, that has a value of 1, and then that term's left over, so it comes out to being 2 minus 2 cosine of U cosine of V plus 2 sine of U sine of V. Yes, it's a long and ugly term, but essentially that's what the value of a C squared equals if I'm using the distance formula. Now take a look at this. Another way I can compute this value right here is by using the law of cosines. And interesting enough, you remember from previous sections, the law of cosines is basically this side squared, C squared, is equivalent to A squared plus B squared minus the 2A cosine of the big C. Well, the big C here, this is my big C. The big C is nothing more than U plus V. So this is equivalent to cosine of C, of big C I should say. So using that knowledge, I can come back and I can say, alright, I can use my laws of cosines and say, well, my one side squared is obviously 1. The other side squared was 1 squared. Minus 2 times 1 times 1 times the cosine of c, but in this case the cosine of c is nothing more than u plus v. So that gives me obviously a quantity of c squared is also equivalent to 2 minus 2 cosine of u plus v. Now notice what I have. I have a value of c squared here equaling this. And I also have a value of c squared equaling this. So guess what I do? I set these two equal to one another and solve from there. And that looks something like this. So if I take this value of 2 minus 2 cosine of u plus v and set it equal to the other value that I have for c squared, which was 2 minus 2 cosine of u cosine of v plus 2 sine of u sine of v, that's a u there. I can see through here. I can eliminate a 2 and a 2 there, and dividing through by a negative 2, I'm left with this quantity. Cosine of u plus v is equivalent to cosine of u times cosine of v minus sine of u times sine of v. And guess what? That is my formula for the cosine addition, for the addition formula for cosine. And we can use the addition formula for cosine in the example that Professor Axler asked us to do in example 1. Says find the exact expression for the cosine of 75 degrees. Well, we got to first find out how we can break down 75 degrees. We hopefully can realize that that is nothing more than 45 degrees plus 30 degrees. And if we want to find the exact value of cosine of 45 degrees, that means the cosine of 75 degrees. That means that is nothing more than the cosine of 45 degrees plus 30 degrees. And you can see how this sets up. That is nothing more than cosine of u plus v. And remember that the cosine formula that we just came up with looks exactly like that. So I need to substitute the values in. So I need to know what essentially the cosine of 45 degrees is, and we should be comfortable with that, as that's the square root of 2 over 2. We need to know what the cosine of 30 degrees is, and we should hopefully be comfortable with that being square root of 3 over 2. And I also obviously need to know what the sine of u is, which in this case is sine of 45 degrees. And that is also square root of 2 over 2. And the sine of 30 degrees, which is the cosine sine of v, which comes out to being 1/2. And when I substitute that all in, I'm left with the cosine of 45 degrees, or u, plus 30 degrees, which is v, comes out to being the square root, after subbing in, square root of 2 over 2 times the square root of 3 over 2, minus quantity square root of 2 over 2 times 1/2, and that all comes out to being the square root of 6 minus the square root of 2 all over the value of 4. So that is my exact value, or exact expression, for the cosine of 75 degrees. And to find the subtraction formula for cosine, I'm actually going to refer back to my addition formula for cosine. But first I need to make sure to point out some things that we should be familiar with. And that's simply, if I take the cosine of a negative angle, in this case I can call it negative v, that is equivalent to just the cosine of v. And likewise, if I take the sine of a negative angle, negative v, that's going to give me a negative sine of v. And these are properties that we learned in previous sections. So I'm going to utilize that concept, and I'm actually going to replace this v value with a negative v, a negative angle. And the reason I'm doing that is because now I can rewrite that as cosine of u minus v. And now substituting that value in, I got a cosine of u times the cosine of a negative v, which obviously we know is cosine of u cosine of a positive v, because that's what that identity right over there tells me. Then I continue on, I got minus sine of u, sine of v, negative v, and this tells me that I got simply sine of u, and this is going to be a negative value of sine of v, which rewriting it now simply becomes cosine of u, cosine of v, plus, because my negative distributes through, sine of u, sine of v. So this ends up being my subtraction formula for cosine right here. So that is how I derive my subtraction formula for cosine. So again, that ends up being my subtraction formula for cosine. I hope this has helped, and remember to check back to ISOmath for all your math needs. Till then, see you soon.